In the last session 2, we completed atomic number, the concept of atomic number. Now, in this today's session 3, let us discuss about atomic mass, that is mass number. Let's say it is mass number. Mass number. Okay. Mass number is denoted by capital A. Mass number represents sum of the protons and neutrons present in the nucleus. For example, uranium 92-235. So in this, this represents mass number, and this represents atomic number Z. So this mass number represents sum of the protons and neutrons present in the nucleons. So together we can call them as nucleons. So the mass number represents sum of the nucleons present in the atom. Okay, what are nucleons? The particles which are present inside the nucleus, they are called nucleons. Okay, so the mass number is 235 for uranium 92-235. Next, another example, let us take uranium 92-238. In this, mass number is 90, that is mass number is 238, and this is represents atomic number. Okay, now so uranium 92-235, number of electrons, that is equal to the atomic number, that means 92, and number of protons, that is equals to, that is, this is mass number, that is 235, in that we have 92 number of protons, and neutrons, that is equals to mass number, that is number of neutrons is equals to mass number A minus Z, that is equals to 235 minus 92. So that number represents the number of neutrons. Similarly, in this, the number of electrons are equal to atomic number, that is 92, and the number of protons are equal to, that is in this 238, we have 92 number of protons, and the number of neutrons, that is equals to, that is A minus Z, that means, that indicates 238 minus 92, that shows 146 number of neutrons in this. So that is the concept of mass number. Once again, the mass number of an element, or you can say the mass number of an atom, that represents sum of the protons and neutrons, so together represents mass number. Okay, so and the next concept is atomic weight. Next concept is atomic weight. Atomic weight. See this atomic weight, the difference between atomic weight and mass number. Whereas the mass number is a whole number for any element, it should be a whole number, it cannot be in fractional. Whereas atomic weight, it can be whole number or integer. Okay, or it may be a fractional value, because see the atomic weight of an element generally can be calculated as average of isotopic masses. It is the average of isotopic masses. So the atomic weight of the element. See, for example, let us calculate. See, generally we have sodium, for example, atomic weight of sodium is 23, it's a whole number. And oxygen atomic weight is 16, it's also whole number. And chlorine, so the atomic weight of chlorine is 35.5, it is in fractional. And whereas boron is 10.8, the round figure we are considered as 11, so it is 10.8. So that is the atomic weight of the element, it can be a whole number integer or it can be a fractional value. So now let us see some examples how to calculate atomic numbers of the elements. So how it is average of isotopic masses. Let us take the first example as boron naturally occurs in two isotopic forms, that is boron 10 and boron 11. Boron 10 isotope occurs 20% in the nature and boron 11 occurs 80% in the nature. The naturally occurring boron, it is available in two isotopic forms, boron 10 and boron 11. The boron 10 occurs 20% and boron 11 it is available 80%. So calculate average atomic weight of boron. Average atomic weight of boron, that is equals to atomic mass into percentage of abundance of one isotope plus atomic mass into percentage of abundance by the total percent of abundance, then it is 200 plus 880 divided by 100, that is equals to 1080 divided by 100, that is 10.8. Okay, so the average atomic weight of boron is 10.8. So the rounded figure value we consider as 11 because it is close to the 11. Okay, that is how to calculate atomic weight of the elements. Let us calculate another example, that is atomic weight of chlorine. Okay, so the atomic weight of chlorine can be calculated based on the available isotopes. Okay, so it is very interesting to note that. So chlorine, the naturally occurring chlorine, it is available in two isotopic forms. Chlorine atomic number is Z is equals to 17 and it is available in mass numbers chlorine 35 and chlorine 37. Chlorine 35 and chlorine 37. The relative abundance of these two isotopes is 3:1. The relative abundance of these two isotopes is 3:1. So calculate the average atomic weight of chlorine atom. So the average atomic weight of chlorine, that is equals to atomic mass of chlorine 35 into, it is relative abundance, it is occurring 3/4. This is for one isotope plus another isotope, mass number is 37 into 1/4. So that gives the total that is the average atomic weight of chlorine is 35.5. Okay, that is the calculation for atomic weight of chlorine atom. And another one, let us calculate another third example. This is example 2. Third example, how to calculate atomic weight of naturally occurring neon. Say for example, calculate the atomic mass of neon, naturally occurring neon, which is a mixture of, okay, let us find the data. I'll write here, that is example 3, the naturally occurring neon, it is a mixture of three isotopes. First isotope is 90.5% of neon 20 and second one is 0.25% of, say 0.25% of neon 21 and 9.25% of neon 22. So these are the naturally occurring neon isotopes and their relative abundance. Now, the average atomic weight of neon can be calculated as average atomic weight of neon is calculated as 90.5% into 20 plus 0.25 into atomic mass 21 plus 9.25 into atomic mass 22 by the total abundance is 100. So after simplifying this, you will get that is it is 20.18. So the rounded off value we can consider as 20.2. That is the average atomic weight of the naturally occurring neon. Okay, so in this way we can calculate atomic weight of the elements. And remember this point, atomic weight of the element, it can be a whole number or it can be fractional value. Because why it is a fractional value? Because atomic weight of an element is calculated as the average of isotopic masses, whereas mass number of any element, it must be a whole number. Okay, mass number must be a whole number, whereas atomic weight, okay, it can be whole number integer or it is a fractional value. Okay, now next let us see the isotopes, isobars, okay, that concept. Now let us take the first concept, that is isotopes. Yes, isotopes. Isotopes. What are isotopes? Atoms of the same element. First let us see the definition part of the isotopes. Atoms of the same element. For example, hydrogen H11, H12, H13, atoms of the same element having same atomic numbers but different mass numbers are called isotopes. Atoms of the same element having the same atomic number but different mass numbers are called isotopes. So, what are the similarities of isotopes? Similarities of isotopes. Atomic number is same, Z is same, atomic number is same, atomic number is same, same atomic number, element is same element, element is also same, atomic number is same. So when element is, that is atomic number is same, that is nothing but the same element, then number of electrons are same, number of electrons are same, number of electrons are same. Since atomic number is same, the number of protons inside the nucleus also same, number of protons in the nucleus are also same, and since atomic number is same, they shows similarities in their properties, similar properties, chemical properties, similar chemical properties, they shows similarities in the chemical properties. Okay, that is the concept of isotopes. Once again, the definition of, interesting definition of the isotopes: atoms of the same element having same atomic numbers but different mass numbers are called isotopes. Isotopes possessing similar atomic number, isotopes belongs to the same element, isotopes possess same number of electrons, same number of protons, isotopes resembles in their chemical properties. Okay, what are the differences? Differences: isotopes differs in mass number, differs in mass number, isotopes differs in mass number. Isotopes differs in mass number. Isotopes differs in the number of neutrons. Isotopes differs in number of neutrons. Isotopes differs in physical properties. Isotopes differs in physical properties. These are the few important differences between, that is similarities and differences between isotopes of the elements. Let us see some other examples of isotopes. Okay, so isotopes, some other examples, for example, like yes, another example, that is say example 2. Example 2, uranium 92 235, uranium 92 238. So the uranium, the two different, that is atoms of uranium with same atomic number, but they have different mass numbers, so therefore they are nothing but isotopes only. So that is uranium 92 238 and uranium 92 235. So let us take one more, another example 3. Carbon. Carbon atomic number 6, mass number is 12, and another isotope of carbon atomic number 6, mass number 14. These are the two isotopes of carbon. And let us take isotopes of chlorine. Chlorine, isotopes of chlorine, that is chlorine atomic number 17 and mass number is 35, and chlorine atomic number 17, mass number 37. We know that. Okay, so these are the few examples of isotopes, atoms of the same element possessing same atomic numbers but different mass numbers are called isotopes. Okay, the next concept is isobars. Bars. The next concept is isobars. Isobar. The concept of isobar. Atoms of different elements, isobars, atoms of different elements having different atomic numbers but possess the same mass number. Example, carbon 614, nitrogen 714. These two are isobars. So atoms are different, that is elements are different, so definitely their atomic numbers will be different and therefore possess the same number of, same mass number. So isobars possess, element is different, atoms of different elements with different atomic numbers but they possess the same identical mass numbers are called isobars. Okay, and some other examples of isobars, that is, let us say it is example 1 and example 2. Example 2 can be considered as argon atomic number 18, mass number 40, and another element calcium atomic number 20 and mass number is 40. Yes, argon 40 and calcium 40, that is 1840 and calcium 2040. These two are also considered as isobars. Once again, what are isobars? Atoms of different elements with the same mass numbers but different atomic numbers are called isobars. One more example, let us consider xenon 54, 130, 130 and barium 56 atomic number, mass number is 130. So that is, this pair is also considered as isobars because their mass numbers are identical. Okay, and these are isobars. And so we completed now isotopes, we completed, now it is isobars completed. Now coming to the next one is isotones. Next concept is isotones. Okay, so these points are very important in the examination, that is for EAMCET as well as even in the IP examination also, these points are very important. These isotopes, isobars, isotones, these concepts even important for your mains examination also. So now coming to the next, isotones. Isotones, the examples for isotones, how we can define these isotones, that is atoms of different elements having different atomic numbers and different mass numbers, but they possess same number of neutrons are called isotones. They possess same number of neutrons. Remember that point, isotones possessing same number of neutrons, the remaining all are different. Okay, once again the statement of isotones, that is atoms of different elements having different atomic numbers and mass numbers but containing same number of neutrons are called isotones. Example, isotones. Example 1. First example, that carbon 614 and nitrogen 714. Nitrogen, carbon is 614 and let us take oxygen. Oxygen 816. Now number of neutrons is equals to, we know that A minus Z, that is mass number 14 minus atomic number, that is equals to 8 neutrons are present in carbon 614. Okay, next oxygen 16, that is 8 and 16 minus 8, that also contains 8 neutrons. So both the species containing 8 neutrons, so they are called isotones. What are isotones again? Atoms of different elements having different atomic numbers and different mass numbers but containing same number of neutrons are called isotones. That is first example. Let us work out a second example. So to become familiar, we have to work more number of examples, then the concept will be understood and we can remember it properly. So isotones, the next example is sodium 1123 and magnesium. Sodium 1123 and magnesium 1224. Okay, now the number of neutrons in this, that is equals to 23 minus 11, that is equals to 12 neutrons present in this sodium 1123 and number of neutrons in magnesium, mass number 24 minus atomic number, that is sum of the protons and neutrons together they are 24, and from this subtract number of protons, then you will get, so 12 neutrons present in this. So that is sodium 1123 and magnesium 1224. Here carbon 614 and oxygen 816. These two are, we can consider as examples for isotones. Let us consider one more example, silicon 1430 and phosphorus 1531. Let us see silicon 1430, whereas next one is phosphorus 1531. Let us take another one, sulfur atomic number 16 and mass number 32. Yes, they must be the pair of isotones only. Let us see. So A minus Z, number of neutrons for all the species, A minus Z, for them that is 30 minus 14, it contains 16 neutrons. 31 minus 15, it contains 16 neutrons, and in this 32 mass number minus 16 number of proton, that also contains 16 neutrons. Yes, all these three species, they contains same number of neutrons, therefore they are considered as isotones. Yes, isotopes, isobars, isotones is done. We completed. Next concept is isodiaphers. Next concept is isodiaphers. That is another interesting topic. Isodiaphers. Yes, isodiaphers. Yes, the statement of isodiaphers. Atoms of different elements having different atomic numbers and different mass numbers, but possessing the same isotopic number are called isodiaphers. What are isodiaphers? Atoms of different elements, or you can say the species possessing same isotopic number, are called isodiaphers. Okay, the species possessing same isotopic number. What is that isotopic number? A minus 2 into Z, that is isotopic number. A minus 2Z, that is called isotopic number. Okay, once again the statement of isodiaphers. The species possessing same isotopic number are called isodiaphers. Okay, example for isodiaphers. Let us work out the example of isodiapher. Fluorine 919, yes, sodium 1123 are considered as isodiaphers. They are considered as isodiaphers. Let us check. So that is isotopic number. For these two species, A minus 2Z, mass number 19 minus 2 into atomic number 9, that is 19 minus 18, that is equals to 1. The isotopic number of fluorine 919 is 1, and sodium 23 minus 2 into atomic number 11. So 23 minus 11 to the 22, then it is equals to 1. So both the species containing, that is fluorine 919 and sodium 1123, they are called isodiaphers because they possess the same isotopic number. So this is the concept of isodiaphers. Okay. So in this session 3, we are doing, one is isotopes completed, second one isobars completed, and third one isotones completed, and fourth we have done, that is isobars is completed. Let us see one more, isosters. Okay, that is another interesting bit and very important, isosters. The concept of isosters is the species, or you can say the compounds or molecules. Let us use the word species. The species containing same number of atoms, the species containing same number of atoms and same number of electrons, the species containing same number of atoms and same number of electrons are called isostars. They are called isostars. Example of isostars. Example of isostars. Let us see the example of isostars is the very good example let us consider, that is carbon dioxide and nitrous oxide. Okay, can you recognize this? Nitrous oxide is commonly known as laughing gas. Okay, so now carbon dioxide. Now let us see the number of atoms. First, number of atoms. Number of atoms. So in this molecule, 1 mole of carbon dioxide, this 1 mole of carbon dioxide is possessing 1 carbon atom and 2 oxygen atoms. That means 1 gram atom of carbon and 2 gram atom of oxygen. So total we have 3 in this. 3. Similarly, whereas in nitrous oxide we have 2 nitrogen atoms, that is 2 gram atom of nitrogen and 1 gram atom of oxygen. So that also contains 3 atoms. So these two, carbon dioxide and nitrous oxide, they possessing same number of atoms, that is same number of gram atoms, or rather we can say the same number of atoms. Okay, next, number of electrons. Number of electrons. Number of electrons, how many are there? Yes, carbon atomic number 6. Okay, it contains 6 electrons, plus each oxygen atomic number is 8. So 2 oxygen atoms are there. So therefore 8 to the 16 electrons of oxygen. 16 electrons of oxygen. So that is total is equals to 22 electrons present in CO2 molecule. So 1 mole of CO2 molecule contains how many electrons? That is nothing but 22 electrons. Okay, similarly nitrous oxide, nitrogen atomic number is 7. So 2 nitrogen atoms are present. So therefore for N2 molecule total we have 7 plus 7, 14 electrons of nitrogen. 14 electrons of nitrogen, and oxygen atomic number is 8. So therefore we can say 8 electrons of oxygen. So total sum is equals to, so that is 22. So that is both carbon dioxide and nitrous oxide both contain same number of atoms, right? And both contains same number of electrons, that is 22 and 22 electrons. So this is one example of isostar. That is one example. Say it is example 1. Let us work out one more example, that is example 2. Let us see that benzene C6H6 and B3N3H6. This is benzene, we know that. Benzene, this is called borazine. Z-I-N-E, borazine, that is inorganic benzene. It is also called borazole. Okay, that you will study in intermediate first year only, that is in the 11th class. Okay, so now in this, number of atoms, that is equals to, so 1 mole of benzene molecule contains 6 atoms of carbon and 6 gram atoms of hydrogen. Total 6 plus 6, together it contains 12 atoms. Together it contains 1 mole of benzene contains total 12. Next, 1 mole of borazole contains 3 boron atoms, 3 nitrogen atoms and 6 hydrogen atoms. Total 3 plus 6, the total is equals to 12. Both contains same number 12. And number of electrons, let us check. Number of electrons in them, that is equals to carbon atomic number is 6. So that carbon contains 6 electrons. 6 are 36, plus hydrogen atomic number is 1. 6 hydrogen atoms are there. Therefore 6 electrons of hydrogen, the total is equals to, that is 42 electrons are present in this benzene molecule. Let us work out this borazine. So boron atomic number is 5. Boron atomic number is 5. So 3 boron atoms are present. Okay, so 5 3s are 15 electrons of boron. Because boron atomic number is 5, so 3 boron atoms. So 5 3s are 15 electrons of boron plus nitrogen atomic number is 7. So 3 nitrogen atoms are there. So therefore that is 7 3s are 21 electrons of nitrogen plus hydrogen 6 electrons. The total is equals to, yes, it is 7 plus 5, yes, 42. Yes, both contains 42 electrons. So this is about isosters. Concept of isosters is done. Okay, right.